I am Dr. Ramkrishna Ghosh, an Associate Professor of the Department of Information Technology of Haldia Institute of Technology. Today, our discussion is model fitting in machine learning. What is model fitting? Model fitting in machine learning is the process of training a machine learning model to learn patterns from data. A good machine learning model should have low bias and low variance. There are three possibilities: good fit, underfitting, and overfitting. What is good fit? A good fit is a machine learning model that captures the underlying patterns in the data without memorizing noise or without memorizing missing important relationships. It performs well on both training and test data. A good machine learning model should have low bias and low variance so that it can perform well on both training and test data. Characteristics of good fit: it has high training accuracy, it has high testing accuracy, small difference between training and testing performance. It has good generalization to new unseen data. It has balanced model complexity. And obviously, it has low bias and low variance so that it can perform well on both training and test data. What is underfitting? Underfitting experiences high bias and low variance. Underfitting occurs when the model is too simple to learn the underlying patterns in the training data. Example, using a straight line, that is supervised linear regression, to fit highly curved data. Straight line through the curved data. Characteristics of underfitting. Underfitting performs poorly on both training and test data. So there is high training error, there is high testing error, poor prediction accuracy, cannot capture complex data complexity, or cannot capture the pattern well. Causes of underfitting. The model is too simple. There is insufficient training time. There are very few features. Excessive regularization. Poor feature engineering. Feature engineering is the process of extracting, transforming, and selecting important features from the raw data to improve the performance of the machine learning algorithms. Poor feature engineering is the cause of underfitting. Noisy or poor quality data. Insufficient training data. How to reduce underfitting? Increase model complexity, add more features, train for more iterations, epochs, reduce the regularization, use better algorithms so that it can generalize well to new and unseen data. What is overfitting? Overfitting experiences high variance and low bias. Overfitting occurs when a model learns both the patterns and noise in the training data. Example, a very deep decision tree that perfectly classifies the training data but performs poorly on new unseen data. Very wavy curve passing through almost every point. Characteristics of overfitting. Overfitting performs well on training data but poorly on test data. So There is high accuracy on the training dataset. There is low accuracy on the testing dataset. Overfitting has high variance. It is very sensitive to small changes in the training data. Learns noise and outliers. It has poor generalization to training data. There is large gap between training and testing performance. Causes of overfitting. Complex model. There is insufficient training data. Too many features compared to number of samples. Training for too many iterations, epochs. Presence of noisy or irrelevant data. How to reduce overfitting? Collect more training data. Use cross-validation. Cross-validation is a technique to reduce overfitting and to improve the performance of the model. Model is too complex, so simplify the model. Apply regularization. Regularization is a technique to reduce overfitting. L1 or L2. Perform feature selection. Apply techniques like dropout in neural networks. Dropout is a technique where neurons are deactivated. Use early stopping during training. Use ensemble methods where multiple models are combined to make predictions and to improve the performance of the model accuracy. Ensemble methods such as bagging. Popular example of bagging, random forest, where multiple decision trees are combined to overcome the problem of overfitting. Decision tree suffers from overfitting. And random forest overcomes the problem of overfitting. Difference between overfitting and underfitting. Overfitting, model is too complex. Underfitting, model is too simple. Overfitting, training accuracy is very high. Underfitting, training accuracy is very low. Overfitting, bias is low. Underfitting, bias is high. Overfitting, variance is high. Underfitting, variance is low. What is bias variance trade-off? The bias variance trade-off is a fundamental concept in machine learning that explains the balance between underfitting and overfitting. Today, I am ending here. I will come back soon with update videos. I will be genuinely grateful for your love and support. If you like my content, you can subscribe my YouTube channel. I look forward a fruitful support and cooperation. Thank you so much for watching this full video. Please stay tuned.